In Unit 10, Program 4, we'll be simulating what happens at a bank. Before we get started, let's discuss a number of preliminary items. First, this function, chance, was described in the program specification. We pass in a number, a probability like 0.2, and then chance returns true with that probability. Chance of 0.2 has a 20% chance of being true and the remaining 80% chance of being false. Next, we'll find it useful to have these three numbers defined. The number of seconds in a minute is of course 60. Once we know that there are 60 seconds in a minute, then since we also know there are 60 minutes in an hour, we can multiply to get the number of seconds per hour. That's 3,600, but it will be easier for us to just use the name, seconds per hour. Finally, our bank will be open from 9 a.m. to 5 p.m. That's 8 hours. So if there are 3,600 seconds per hour, there are 8 times that many in a full workday. This number is 28,800, but again, in our code, it will be easier to use the name. Let's skip this line for a moment. We'll come back to it and look to see what the main part of the program will do. We'll be running a simulation 10 times. Each time we'll use this code here to find out the average length of the line in a bank. For each simulation, we'll be creating a bank using a class that we'll need to write. Writing the bank class will be the main work for this program. Our bank will have a time attribute. This tells us how long the bank has been open on the day that we're watching. Time will be measured in seconds. So time will be 0 when the bank opens, 1 after 1 second, 2 after 2 seconds, and so on. We've calculated that there are 28,800 seconds in a workday. So time will increase 0, 1, 2, all the way up to 28,800. In this loop, the main work is on this line. Our bank class will have a method called do1second that takes care of simulating all the things that happen in a bank during 1 second. One thing that happens for certain is that the time attribute increases by 1. In each second, the time is 1 second later. So time will be 0. This function will increase it to 1. Time will be 1. This function will increase it to 2, and so on, until 28,800 seconds have elapsed, and that's 1 full day. During each second, the time will increase, and other things may happen as well. For example, a new customer may arrive, or one that's being served by the teller may complete their transaction and leave the bank. All of that will be work for us to include in the do1second function. Our bank class will also have a method that tells us how many people are online at the bank. So for each of the seconds that the bank is open, we'll take the number of people online and add it to a total that starts at 0. We'll be adding 28,800 numbers to total. When we're finished with the day, we'll take the total of all of those 28,800 line lengths and divide by 28,800. That will give us the average length of the line during that day, which will be reported using this format. We'll continue from here in the second part of this screencast.